right, here we go. Unit 4, lesson 8. Athlete for today is Steve Nash. My sister got me a pack of Panini Prisms. This is like a throwback card. But Steve Nash was a bit of a late bloomer. Guard averaged 7.2 points over his first 4 seasons. Didn't make his first All-Star game until he was 27 years old. Once he figured it out, he really figured it out. He went on to lead the NBA in assists per game 5 times and win a pair of league MVP awards. This guy was the man. He's from Canada. That explains why his points per game were so low to start out. But yeah, once he got it going, he was unstoppable. He was such a good shooter. One of the first 50, 40, 90 guys. 50% field goals, 40% threes, 90% free throws. But anyway, here we go. Lesson 8, practice problems. Select all the true equations. So the first thing you need to know here is this is the concept you need. The concept is with complementary angles, and that's 2 angles adding up to 90 degrees. So with complementary angles, 2 angles that add up to 90 degrees, sin of one will equal cosine of the other, and cosine of one will equal sine of the other. So if you got like a 15 and a 75, 2 complementary angles, then sine of 15 will equal cosine of 75. Sine of 75 will equal cosine of 15. Okay, so here we go. Select all the true equations. Cosine 15, sine 15. The thing I already can tell, these can't be the same number. Cosine 15 would equal sine of 75, but not sine of 15. Okay, cosine of 75, sine of 15, so these are switched, so that's good. And these add up to 90, so that's good. Cosine 75 equal cosine 15, no, these have to switch. So cosine 75 will equal sine of 15. So that's no good. Cosine of 15 equals sine of 75. Yep. And lastly, tangent doesn't apply, so don't worry about tangent. It's just cosine and sine. For complementary angles, sine of one will equal cosine of the other. Cosine of one will equal sine of the other. And your example is 1575. So your answer is B and D. Okay, we'll write 2 expressions that can be used to find the value of x. So here's x right here. Okay. So why don't we color the 25 then? Okay, this is hypo, and this is adjacent. So the first one you could write is, and we could even write SOHCAHTOA if you want to make this manageable. So we got the A and the H, A and the H. So you could write cosine 25 equals adjacent x divided by hypotenuse 11. All right, so there's cosine of 25. Okay, now this is gonna be interesting. We're gonna color this angle in orange. Now, what you're gonna notice is this is no longer adjacent, this is opposite. Okay, opposite 65. Now let's look at SOHCAHTOA again. What has the O and the H? Well, that's So. So then you can write sine of 65 equals opposite divided by hypotenuse. So x over 11. Now notice, let's see, x over 11, x over 11. These two are the same. That means these two are the same. So by this example alone, you now see an example of complementary angles. Cosine 25 equals sine 65. There's another example. 25 plus 65, two angles add up to 90. So anyway, these are your two equations, 1 and 2. So that's your two expressions, 1 and 2, right here. Cos 25 equals x over 11, sin 65 equals x over 11. This is just bonus. You now know that the right sides are equal, so then the left sides are equal. Okay, Andre and Mai are discussing how to solve for side AB. AB, okay, they labeled it x, good start. Andre thinks he can use the equation tan 12. So there's your 12. Color in your angle. Opposite adjacent. This is always hypo because it's across from the 90. So tangent of 12 will equal opposite over adjacent, x over 6. So that's good. Andre's right. Now, Mai is thinking, what if we use this angle instead? Which, because this is 12, this would be 78. So Mai is like, all right, I'm gonna use the 78 instead. That would make this one adjacent, this one opposite. Opposite adjacent of the 78. Opposite adjacent. Opposite adjacent. So for 78, TOA, tan 78 would equal opposite over adjacent. So tan 78 would equal 6 over x. That's what Mai's using. She can use tan 78 equals 6 over x, which we just showed. So they're both correct. So I agree with both. Because, and here's a good reason, because tan 12 equals opposite over adjacent, x over 6, and tan 78 equals opposite over x, 6 over x. Okay, cool. Number 3. Yeah, let's put that over here. Number 4, Jada visiting New York City to see the Empire State Building. Gosh, I wish I knew off the top of my head what that looked like. So she is 100 feet away when she spots it. To see the top, she has to look up at an angle of 86.1 degrees. Okay, doke. So we're gonna draw the Empire State Building. I forget what it looks like. Shoot.
You forget what it looks like?
Claire. It's okay. Okay, so let's just draw like a building. Like so, need some supports. Okay, so here's our building support. This is not the greatest. Oh well.
Can I tell you what it reminds me of?
Sure.
A squid.
A squid?
Yep.
Cool. All right, so here's our Empire State Building. Okay, so this is the Empire State Building. In New York City. All right, now we're gonna start drawing a right triangle. Top's important. The base of the building's important. Why don't I use red for the triangle? Okay. And then Jada, sorry, is 100 feet away, looking way up. I'm gonna try to make it look somewhat close to this size angle. It's not gonna be perfect this time, but that's okay. Okay, so we are building a right triangle. Here's our right angle. If you need to shade it in to make it work, well, let's just shade the angle in. Okay, so Jada's right here. And she's looking up to the top. She's 100 feet away. The angle is 86.1 degrees. Okay, how tall, we'll call this the height, is the Empire State Building. So all you're given is this angle of 86.1 plus this 100. You got a side plus an acute angle. You got to figure out this side. Pretty simple stuff. Let's label. It's opposite. 100 is adjacent. Let's look for the O and the A. I'm going a little faster now, but here's the step. Which one has the O and the A? TOA. So we're gonna do an equation. Tangent of our angle equals opposite. That's what the O stands for. Divided by adjacent. What's our angle? 86.1. So here we go. Tangent 86.1 equals. So that's 14.669 equals. Opposite was height. Adjacent was 100. Now you just gotta cross multiply. So h times 1 is h. 14.669 times 100 is 1466.9. So 1466.9 feet. So we are going to say that the height of the Empire State Building is 1467 feet. Number 5, find the missing measurements in triangle ABC. Well, there's 1, there's 2, and there's 3. So let's set up our finish. X equals Y equals Z equals. So here's your finish. Okay, now let's chip away. Color in your angle, first step. Label your sides. Opposite. This is hypo. We're just gonna use, if you look closely, you got the H and you got the O. So we're gonna use so. So, ka, toa. So ka toa. Got a little assistant here in front of me. Anyway, O and H. So we're gonna use so of this angle. So sin 35 equals, I always like to do this, op over hypo. Just because it helps you like organize your thoughts. Now you could run it right here. Opposite is x, hypo is 9, sin 35.574, so 0.574 equals x over 9, cross multiply, x equals 9 times 0.574, so x equals 5.162. So we're gonna call this 5.2. Okay, now let's get y. To find y, I'm going to use Pythagorean theorem, which is a squared plus b squared equals c squared. Now you just got to get good at what's what. So we got 5.2 squared plus y squared equals c squared, which is 9 squared. So 5.2 squared, well, I'm just using my old answer, but it's 26 point, well, let me just do it for you. This is where rounding early can kind of let's see here. Yeah, I'll just roll with it. It's okay. I rounded a little early, so we'll just run it. 27.04 plus y squared equals 81. So you're gonna get y squared equals 53.96. Square root both sides. Y will equal square root of 53.96, which is 7.35. So we're gonna call y 7.4. Okay, so this is 7.4. We're almost done. And then to get z, that's just 90 minus 35, which equals 55. So z is 55 degrees. How do I know that? Because all three add up to 180. If you took the 90 out of it, there's 90 left. So this plus this equal 90. So this equals 90 minus this. 90 minus 35, so this is 55 degrees. All right, number 5, done. Okay, number 6, right triangle ABC is shown. All right, ABC is shown. Write 2 expressions, so 2 like equations, which are equal to the length of side BC. All right. I'm just gonna call this little a. All right. Okay. So BC equals A. Now, I have two sides of a right triangle. So you could just say A squared plus B squared equals C squared. Pythagorean theorem. So A squared plus 4.9 squared equals 6 squared. So A squared plus 4.9 squared, 24.01 equals 36. So A squared equals, subtract both sides. These cancel out. 11.99. So A will equal the square root of 11.99. And BC equals A, so that equals BC. There's one. Now we're gonna get one more. Okay, now for this one I want to use this 55-degree angle right here. Okay, so color in your angle, label your sides. This is gonna be ADJ. This is hypo. This is OPP. Now, I want to use the cleanest numbers, so I'm going to use the 6 and the A. So, ka, toa. Which one has the A and the H? Ka. So you'll say cosine of whatever angle equals ADJ over hypo. What's our angle? 55. So you'll say cosine 55 equals ADJ, which was A, over hypo, which is 6. Cross multiply. A equals 6 times cos 55. So A equals 6 times cos 55, 3.44, which equals BC. So here was our first one, here was our second one. So there's your two expressions. Okay. All right, 6 down. 7. Triangle has sides with like 7, 24, and 25. Verify this is Pythagorean triple. Okay. We just got to verify if A squared plus B squared equals C squared. So if A squared plus B squared equals C squared, then we have a Pythag triple. So if then statement. So let's run it. So if 7 squared plus 24 squared equals 25 squared, then we have a Pythagorean triple. So it is 49 plus, I think it's 576. Let's see. 24 squared, 576. Does that equal 625? We shall find out. It's 576 plus 49 equals 625. It sure does. So, boom. There you go. There's your proof. We proved it. Yeah. Okay. Approximate the acute angles in this triangle. This one's tough. 7, 24, 25. Let me see if I could even draw that. Where's my ruler when I need one? Anyway. I'm just gonna use this up here. It's not ideal, but hey, whatever. The main thing I'm trying to do is get the figure drawn so then I can approximate the acute angles. So 7, 24, 25. And we got to get the acute angles. So let's just call this puppy A, B, C. So angle A equals angle B equals, setting up our finish. So first step, color in an angle. We're going to use angle A. Label your sides, opposite, adjacent, hypo. Okay, I'm gonna use, you could use any of them, but I'm gonna use O and H. So I'm gonna write so, ka, toa, figure out which one is which. I'm gonna use O and H, so I'm gonna use that one. So you say sin of your angle, which we don't know yet, equals opposite over hypo, which we do know, opposite 24, hypo 25, 24 divided by 25 is 0.96. So sine of A equals 0.96. Now you could use the ratio tables, but this is the easiest way. You go second sin 0.96 equals, and I'm gonna draw rectangles so they look like buttons. So second sin 0.96 equals. That's going to give you A. Second, wait, let me clear up. Second sin 0.96 equals 73.7. So we're going to say 74 degrees equals A. A, 74. Write it in so you don't mess up. Then you just got to get angle B right here. This is just going to be 90 minus 74 equals 16. There you go. Number 8, Priya is playing handball and wants the ball to bounce off while CB and land at D. So she's playing handball, so she's hitting the handball here. And she wants it to land at D, okay? The court is 20 feet wide, okay? And 34 feet deep. Let me just figure that out. 20 wide, 34 deep. Where on the wall should she aim if she's standing at point A? So weird. 18 plus 12. Oh, I see. Okay. So 20 wide, 34 deep. 18 plus 12 is 30, meaning this is 4. All right. 27 goes from here to here, and then 34. So this is 7, right? 27 plus 7 is 34. Okay. All right. Now check this out. We've got a pair of angles and a 90 in each. So these two triangles are then similar because of angle. Okay, meaning let me think here. We have to figure out where on the wall should she aim if she's standing at point A. Let me think. Let me think here. What am I missing here? How could I figure this out? Let me think. A little stumped on this one. Let me think why that is. Gonna figure this out. I just need one more side. Why am I blinking? I know that's 16 and 4. It's gotta be. I'm thinking this is 16 and this is 4. I can't just make that assumption. Let me think.
Use geometry.
Mm-hmm. No, this is 20. Okay, I know for a fact that if we rotate, sorry, if we, you can have a 7 there. We call this X. BE is Y. Alright. So X plus Y equals 20. I know that. That'll be X. This whole thing will be Y. Okay, so here we go. All right, so 12 over Y will equal. So we got 12 over Y, this big one, will equal 7 over X. And because X plus Y equals 20, X will equal 20 minus Y. So let's rewrite this. 12 over Y equals 7 over 20 minus Y. I think we're almost there. Now you just cross multiply. So 7Y will equal 12 times 20 minus Y. So 7Y will equal 12 times 20 is 240 minus 12Y. We're almost there. So we're gonna add 12Y to both sides. So these cancel out. So you're gonna get 19Y equals 240. Divide by 19. Divide by 19. These cancel. So Y equals 240 divided by 19. 240 divided by 19. 12.63. So this whole thing is 12.63, meaning that X should be 20 minus 12.63. So looking at 7.37. So this is 7.37. So finally figured it out. If she's at point A, she needs to aim for a point that is 7.37 feet away from C. So to answer this, where on the wall should she aim if she's standing at point A? Priya should aim 7.37 feet away from point C. Here's my final answer. And how did we do it? Well, we started with knowing that we had two pairs of angles congruent. Then we rotated, I think we rotated 180. Let me just think. This side ended up over here. Yeah. No, we didn't rotate 180. We just basically reflected over this line to get here. So we had two similar triangles. Then you can set up 12 over y equals 7 over x. Then we had two unknowns, so I had to do some logical thinking to remember that x plus y equals 20. And from there, we were able to change x to this, 20 minus y, and then just sub it in. And that way we only have one unknown. Yeesh, that was a tough one. I wasn't ready for that. Anyway, you saw me struggling a little, and that's okay.
Everybody struggles.
Everybody struggles. Thanks, Blair. All right, adios.